direct Chablis. Clear direct Chablis.
Gave you too much, now I'm swallowed.
Discretion, maintain level 240.
Now I'm the fool while you're breaking rules.
Hello again, everybody. Welcome to
Last
Flight Ops
328,
Academy. My name is
center
Ricardo Bengoa,
125.85.
and this will be my third video regarding some of the subjects we need to teach here in our Aviation Academy. One of them being weather, one of the most important ones. And I figured before I move on into more particular weather, one of the things that we really have to learn is altitude. And I figured I could combine altitude with altimetry and knock off both of those subjects. This is an excellent book, Aviation Weather, teaches you all about weather. It's also free online, and we have it on our computers here for our students to use. All right, first thing we're going to do is review of the last video. We talked about the International Standard Atmosphere. That would have a temperature of 15 degrees Celsius, a pressure of 29.92 inches of mercury. That, of course, is at sea level. Now remember that our standard lapse rate, for every 1,000 feet, you're going to cool 2 degrees Celsius, and for every 1,000 feet, you're going to lose 1 inch of mercury. This is basic knowledge, and you should memorize this. Also, for a review, hot air expands. The hotter it gets, the bigger that particle gets. That affects performance, and air cools with altitude as it rises. That's at least standard. There's less air pressure at altitude, which is going to affect your aircraft performance. And now let's talk about an altimeter. Your basic altimeter is just like a clock. The big needle is going to point to the hundreds of feet. The little needle is going to point to the thousands of feet. And there's a lot of variations to this instrument. Now the important thing to learn is what it measures is actually pressure, and that is it. It doesn't measure anything other than pressure. The way it does this is by having an aneroid wave attached to it with a constant pressure inside of it. So if you climb, there's less pressure, it will expand, and if you descend and there's more pressure, it will contract, moving the needles in the altimeter. Alright, now I'm simply going to show you the different types of altitude that are out there. It might be a little weird for somebody to understand this, but there's different ways of measuring altitude. The first one we're going to talk about is indicated altitude. That's simply the altitude the altimeter is reading. Don't read any more into this. That's it. Whatever the altimeter says, that's indicated altitude, uncorrected for anything. Next altitude is pressure altitude. That is essentially the altitude that the altimeter should indicate if at sea level it were 29.92 inches of mercury. In other words, if everything was standard, you should be indicating pressure altitude. Next one is density altitude. This is the pressure corrected for the temperature. Remember that when you warm up air, it expands. So now we're taking into account that heat and the pressure to come up with another altitude. True altitude, otherwise known as MSL, is mean sea level altitude. Your altitude above sea level, regardless of where you're at. This is the altitude corrected in case the atmosphere is not at 2992 that day. The last altitude we're going to talk about is absolute altitude, or AGL, above ground level. This is simply the altitude the aircraft is over the ground. It's rarely measured with an altimeter. It needs another equipment called a radio altimeter. Or you can do some math. Alright, I'm going to leave this up for 15 seconds. I recommend all of you to pause the video, write all this down. You will need to know what each of these altitudes mean. So take your time and learn this. A great resource for aviation weather is, of course, the Aviation Weather book. It is called AC006 Alpha, and I'll put a link for it at the bottom of this video. It gives you explanations with some 1960s illustrations. And I'm going to explain a little bit of each one of these altitudes. Absolute altitude, or AGL, as is commonly referred in aviation, is simply your altitude above whatever ground that aircraft is flying over. Whether it is 1,000 feet off the ground, 700 feet off the ground, and it's not very much used unless you're looking for limitations for flying over certain terrains. Now, as a dispatcher, you don't get to use AGL too much unless you're going off route. And in the case of the pilot, the only time they ever use it or measure it is with a system called the radio altimeter. This one sends a signal down to the ground at the speed of light, bounces back up to the airplane, measures the differences in time, and tells the pilot the altitude above ground. The only other way to measure AGL is based on your altitude above sea level, and then you would have to subtract whatever region you're flying at. For example, there 1513 is that airport out there, and every chart will give you a minimum altitude to fly in that quadrant in order to be safe from obstacles. Now let's go back to that altimeter, and remember we talked about that wafer having constant pressure and it expands and contracts based on the outside pressure, and that allows it to give a reading to the altimeter. Now, it's not always 2992. In fact, it's most of the time is something different. So we have to have a way to correct for that. That's called an altimeter setting, and that reading is given by your local airfield. Let's revisit pressure altitude. That is the pressure differential that would make the altimeter move if the pressure was 2992. So standard, if you're at sea level, it would read 0. If you're at 3,000 feet, it would read 3,000. But now let's leave that altimeter at 29.92 set and make the pressure difference. Let's call that 28.92. What would the altimeter then read if it was sitting at sea level? It wouldn't be 0 anymore because the pressure is different. And remember, the altimeters work based on pressure. So at an altimeter of 29.92, remember 1 inch per 1,000 feet, that is a 1,000 foot difference. At sea level, it would read 1,000. At 3,000, it would actually read 4,000, unless you correct that altitude window in the altimeter. And the math is pretty simple. 29.92 minus 28.92 equals 1. 1 inch of mercury equals 1,000 feet. Alright, now true altitude, MSL as is commonly known, mean sea level. That is the altitude that you should be reading in your altimeter if you correct it for the pressure differential. That means if it's not 2992, for example 3001, you should put that in your altitude window in your altimeter in order to read the correct altitude above mean sea level. Aircraft that are flying below 18,000 feet must correct for the pressure differential every 50 miles or as close an airport as it can in order to avoid wrong altitudes. This is important, especially over high terrain. That way, the pilot can assure that based on his altimeter reading and the terrain below, they'll be able to clear any obstacles. And in this case, let's try to go the other way, from true altitude, MSL, to pressure altitude. Let's say the altimeter setting is 3001. Your standard ISA is 29.92. That's a 0.09 difference, around 10 feet, really 9 feet. So your pressure altitude, if the aircraft was flying at 6,000 feet, would now be 6,009 feet. Now density altitude. This one is the one that's going to affect performance the most, and it will impact you as a dispatcher. Remember, air, as it heats up, it expands. That means that it's going to affect lift, therefore affect performance. Now let's put a sea level pressure at 3020 and a temperature of 30 degrees Celsius. All right, now let's try to figure out our pressure altitude. 30.20 minus 29.92. That equals 0.28 inches of mercury. Remember, 1 inch per 1,000 feet, that's 280 feet. That would be your pressure altitude. Now let's convert that pressure altitude into density altitude, and welcome to the E6B whiz wheel. And here you'll find two windows, one labeled pressure altitude, another one labeled temperature. You matched your pressure altitude with your temperature, and on top, where it says density altitude, you'll get your answer. Now, according to my now outdated way of figuring out pressure density altitude, I can tell you that density altitude is around 1,200 feet is what I got from those tiny little windows. Now let's go look at it in the 21st century. Okay, in the 21st century we got calculators, and this is a Sporty's calculator donated by one of our students, and it's pretty easy to just input the numbers. Altitude 0, altimeter staring 30.20 with a temperature of 30 degrees Celsius. Press enter, and there it is. Pressure altitude 258, density altitude 1392. Now that we have our accurate number of 1392, that is the number that all performance should be based at. That was a almost 1,400 foot difference. Now let's take a look at this takeoff graph out of Boston. Pressure altitude 20 feet. To the left we see temperature. The hotter it gets, the more restrictive your aircraft will be. The less weight that aircraft will be able to take off with. Alright, now let's give some lame terms to these altitudes. Indicated is just the altimeter. Pressure altitude is your standard, or what everything is based out of. Density altitude is used for performance. True, or MSL altitude, is the actual altitude of the airplane you're going to be referring to, or the flight level. We'll talk about those later. And absolute AGL is used for obstacle avoidance. Thank you for watching. I hope you found this video resourceful and you learned something new. These are some of the things that we need to teach in our dispatch course in order to certify somebody to become a dispatcher. If you want to become a dispatcher, visit us at www.flightopsacademy.com, and I'll see you next time.
328, contact Open Center 125.85. 2585, good night, last 328. Singapore 2, descend up fast discretion.
Gave you too much, now I'm swallowed.
And flight level 240, pilot discretion, Singapore 2.